Understanding Rotations, Lesson 19 notes. Before we do examples 3 and 4, I need to discuss what rotation about the origin looks like. So we are going to start rotating figures around the origin, about the origin on the coordinate plane, and we need to discuss what it's going to look like. So in other words, there's actually a shortcut to find the ordered pairs and to figure out how to graph these without moving anything on the actual grid. So, rotation about the origin. This is where it gets a little odd, but please, let me go through it and then I'll explain more later. Okay, so clockwise. There's two directions, remember? There's clockwise and there's counterclockwise. So let's talk about clockwise first. If we are going clockwise 90 degrees, and your original point for the pre-image was xy, then your image point is going to be y negative x. What that means is, whatever your y coordinate is, it now becomes your x coordinate. Whatever the y coordinate was, that becomes your x coordinate. And then whatever your x coordinate was, you're going to take the opposite of it, and it will become your y coordinate. You'll take the x coordinate, take the opposite, and it will become your y coordinate. Again, I will show you more on this when we go to do the examples. If you rotate something 180 degrees, if you would have done the last problem in, it was part C on the reflections worksheet, what we did was we reflected a figure over the y-axis, and then we reflected a figure of that new figure over the x-axis. And what you ended up getting was actually a 180 degree rotation. And if you remember, to go from the first pre-image to the last image, both coordinates became negative. So in other words, when you rotate something 180 degrees, the coordinates just both become the opposite. So you take the opposite of x and the opposite of y to find your 180 degree rotation. Rotation 270 degrees clockwise. So 270 degrees clockwise is negative y, x. What this means is, whatever your y coordinate was to begin with, you're going to take the opposite of it, and it will become your x coordinate. And then whatever your x coordinate was, it's now your y coordinate. Now, what if we were going the other direction? What if we were going counterclockwise? If we were going counterclockwise, then 90 degrees. Well, if you think about it, let's go down to our example 3 here. If I take this rectangle JKLM and I rotate it 270 degrees, each quadrant is 90 degrees. So from here to here would be 90 degrees. Here to here would be 180 degrees. So from here to that quadrant, that would be 270 degrees. Well, that would be 270 degrees clockwise, but that's the same thing as going 90 degrees counterclockwise. So 270 clockwise is the exact same thing as 90 degrees counterclockwise. So that means that this right here looks the exact same as that up there. So if clockwise 270 is negative yx, then counterclockwise 90 is negative yx. If you take JKLM in example 3 and you go 180 degrees clockwise, or if you go to 180 degrees counterclockwise, it's going to put the figure in the exact same spot. Therefore, it doesn't matter if you go clockwise or counterclockwise, 180 degrees is always the opposite of x, the opposite of y. Now, if I take my figure and I go 90 degree clockwise, that is the same as going 270 degrees counterclockwise. So in other words, 90 degree clockwise is the same as 270 counterclockwise, which means 270 counterclockwise is y, then negative x. All right. So I don't expect you to have that memorized, but you are going to need to make sure you have this ready and able to use it and see it so you can reference it at any time while working on rotations, notes, bell works, and worksheets. If you have any questions, let me know.